When you balance equations, remember to multiply the subscript of each atom by the coefficient. When no subscript is cited, consider it to be 1. The goal of balancing equation is to have the same number of each type of atom on both the left side and the right side of the arrow. This is achieved by changing the coefficient of the compounds.
Here's the first equation. We got xenon and fluorine. We want to keep track of how many atoms of these elements I have on both sides of the equation, so we're going to make a little chart. We put xenon and fluorine on this side and then xenon and fluorine on the other side. On the left side, I have one xenon atom and then I have F2, so I got 2 fluorines. On the right side, we also have one xenon and then F6, so I got 6 fluorines. Now take a look at these numbers. This equation isn't balanced yet because we have different numbers of the atoms for one of the elements. I've got 2 fluorines on the left side, but in the right side, I got 6 fluorines, so it's not balanced. In order to balance it, I've got to add numbers in front of one or more of these elements and compounds to change the number of atoms that I have on the different sides of the equation. This is what we are going to do. On the right side, I got 6 fluorines, but on the left, I got 2 fluorines. So for this to balance, I need more fluorines on the left side. I can add a number in front of the F2. If I put 3 in front of the F2, now I have 3 times 2, which gives me 6 fluorine. And now they balance. 1 and 1 for the xenons and 6 and 6 for the fluorine. Now this is a balanced equation. This equation has 5 different elements in it, and it also has parentheses. First, the number of atoms in the left side. Iron, we have 1, chlorine, 3, sodium, 1, oxygen, 1, and hydrogen, also 1. On the right, we have Fe1, and then we got the parentheses. Okay, so the parentheses mean that everything inside here is multiplied by 3. So we have O times 3, which are 3 O's, and H times 3, that is 3. Then we have Cl and Na that are 1. So this is unbalanced. First, we have an imbalance in the oxygens. We have 3 on the right, but 1 in the left. I am going to put a 3 in front of NaOH. That is going to multiply all the compound by 3. I have 3 Na, 3 O, and 3 H. So what does that do? Well, that balances the oxygens and hydrogens. But now in Na, I have 3 on the left side and 1 on the right side. I can balance the Na from the right by multiplying the elements by 3. So that's going to give me Na3, and it's also going to be 3 times Cl. So now we have 3Cl. Now that I fixed it, I have 3Cl in the right side, but also on the left side. Now they all balance.
This equation has iron with 2 atoms, oxygen with 3, and carbon with 1 on the left side of the arrow. But on the right side of the arrow, it has iron with 1 atom, carbon with 1, and oxygen with 2. This equation is pretty much unbalanced. First, we start by adding 2 as a coefficient to iron and oxygen that will give us 4 and 6. Then on the right side, to balance iron, we add 4 as a coefficient, and now it's balanced. Then to carbon and oxygen, we add a coefficient of 3, that will give us 3 and 6. And then to carbon on the left side, we add 3. Now it's balanced.